Alright, so let's look towards the solutions and different strategies to evaluate these integrals of the integration BE 2024 exam. So let us move on. Okay, so as we know, for question number 1, it's told to evaluate the integral of 2023 to 2025, right? Yeah, of the year 2024 with respect to x. So this would be simply, um, as we all know that it's very much simple. It would be 2024 multiplied by 2, that is 4048. Next question, integral from of x minus of 1 whole to the power log of x plus of 1 divided by x plus of 1 whole to the power log of x minus of 1 with respect to dx. So by using the property of logarithm, as we know that a to the power log of b base c could be written as b to the power log of a base c. I mean, I'm just interchanging these two terms from here. I'm just interchanging these two terms from here. So as we know that as I'll interchange the term, this will just get cancelled out. So this will be going to be evaluated as just as dx. So the answer should be x plus of c. Next question. Question number 3. Integral of x ln x plus of 2x dot dx. Alright. Alright. So for this question, what I'll do is that for my instance, I'll take x as common. So ln x plus of 2 dot dx. So for this case, I'll be using integration by parts, and as we all know, integration of u v dx could be written as u integration of v dx minus of integral of du by dx integral of v dx whole with respect to dx, right? So this could be written as uh, v, and this could be written as u, because why I'm taking it as u, because I don't know the exact integral of ln x plus 2, although I know that it's x ln x minus of x, but for the time being I'll be using it as u. So I'll be getting x squared by 2 ln of x plus of 2 minus of integral of x squared by 2 multiply over of 1 over of x dot dx. So x and x got cancelled, so we're left with x squared by 4 minus of x squared by 2 multiplied by ln x plus of 2. So yeah, here's our answer to this plus c. Yeah, and here's our answer. It's a sin for not writing c. So it's very much important. Yes. Question number 4. It's asking to evaluate the integral of dx over of x ln x plus of 2x. Alright. So for this kind of question, what I'll see is that if I take x as common from both the sides, then I'll be left with ln x plus of 2 dot dx. And if I'll take ln x as t, then for this question, I'll be getting it as integral of dx over of uh, t by t, because ln x could be written as dt. Okay, ln of x plus of 2 could be written as t. dt over of dx could be written as 1 over of x, and 1 over of x will get cancelled, so we are left with ln x. So our answer is ln of x plus of 2 plus of c. Next question. Next question. I believe it's a great question. This is a good question. So from 0 to 2 pi, this could be written as cos inverse of sine of x dot dx. So for this kind of question where I can see that there's a term involving 2 pi. So for this kind of question, what I'll do is that I'll apply King's rule. As we all know, it says that a to b of fx dx could be written as a to b, the same limit of f of x, a plus b, sum of limit minus of x dot dx. Okay, by King's rule. By King's rule, I can say it, right? Yeah, okay. So by King's rule, I can say it. Now, if I'll apply King's rule and if this was I, then I could be written as integration of 0 to 2 pi cos inverse of sine of minus x. We are left with minus x. Why? Sine of 2 pi minus of x is minus of sine x. Okay, so, and as I know, because of this non-symmetric nature around the x-axis of y is equal to cosine inverse of x, cosine of cosine inverse of minus x is written as pi minus of cosine inverse of x. So why I'm writing it down? Because this is not symmetric about the origin. Okay, its function is not such easy for that case. So we, as we all know, that we have made it this function bijective by ourselves, right? So it's not like a natural function like the way sine, cosine, tan, cosecant, and quad perform. So I could be written as 0 to 2 pi cos pi minus of cosine inverse of sine x dot dx. Now, if this is written as equation 1, okay, equation 2, and this is written as equation 1, and if I'll add equation 1 and equation 2, okay, so yeah, so 1 plus of 2, I'll be getting 2 pi is equivalent to 0 to 2 pi pi dx. So from here I'll be getting 2 pi square is equivalent to 2i. So 2 got cancelled, so I is equal to pi square. Next question. Question number 6. Alright, so it's asking for the integral of cos x plus cot x plus of cosecant x plus of 1 divided by sin x plus of tan x plus of secant x plus of 1 dot dx. Alright, uh, for this integral, this integral has something special if you'll observe it very much carefully. If you'll write it down, breaking it away, then you'll be getting cos x plus of cos x by sin x plus of 1 over of sin x plus of 1 whole divided by sin x plus of sin x over of cosine x plus of 1 over of cosine x plus of 1 with respect to dx. Are you observing the nature? The way the pattern is symmetric for the numerator and the denominator. Look, cosine cosine, sine sine lower, sine sine, cosine cosine lower, plus 1. So it's simple, just cross multiply it, so you'll be getting sine x plus of cosine x plus of cos x plus of 1 plus of sine x divided by sine x over of sine x plus of cosine x plus of sine x cosine x plus of 1 divided by cosine x with respect to dx, right? So from here, what I can say is that this could be written as integral of cot x dx. So the integral of cot x is ln mod of sine x plus of c, and here's the answer. Next question. Next question is also very much easy. For question number 7, it's just to evaluate the indefinite integral for x to the power 2024 minus 1 divided by x to the power 506 minus of 1 with respect to dx. Okay, if I'll factorize it, then I'll be getting x to the power 1012 plus of 1 multiplied by the half is x to the power 506 minus of 1 multiplied by x to the power of 506 plus of 1 divided by x to the power 506 minus of 1 with respect to dx, right? So this and this got cancelled, so we are left with x to the power 1012 plus of 1 multiplied by x to the power of 506 plus of 1 with respect to dx. Now this could be written as x to the power, if I'll sum it up, then I'll be getting 1518 plus of x to the power 1012 plus of x to the power 506 plus of 1 with respect to dx. Then the answer to this question would be x to the power 1519 over 1519 plus of x to the power 1013 over of 1013 plus of x to the power of 507 over of 507 plus of x plus of c. And yeah, here's the answer to this integral. Next question. Let me see the next question. Yeah. So the next question is integral of 5x cube minus of 3x whole to the power 2 with respect to dx from minus 1 to 1. All right. So it's asking from minus 1 to 1. So the first thing to observe in this question is that whether this function is even or this function is odd. As we all know, it's very much common that whenever the limit are from minus a to a, we should focus on that whether it's even or odd, right? So if I'll okay, so this is an odd function. Why? Because here f of x is equivalent to f of minus x is equivalent to fx. So this could be written as 0 to 2 to 0 to 1 to 5 x cube minus of 3x is, wait, why I'm taking this 5x cube? I should take x as common first. That would be much better. Okay, yeah, so x square into 5x square minus of 3 whole to the power 2 with respect to dx. So this could be, if this is I, then I could be written as 2 integral of 0 to 1 x square 25x to the power of 4 plus of 925, yeah, but minus of 30x square with respect to dx. So this is like 2 uh 25, right? 25 x to the power 2 25 x to the power 7 by 7 plus of 9 x to the power 3 by 3 minus of 30 x to the power minus of 30 x to the power 3 by 3. But wait, sorry, 4 by 4. This is square, square, and 4, right? Yeah. So this would be 5. 5 x to the power 5 by 5. Okay. So yeah, plus c. And if I'll substitute the limit from 0 to 1, then I'll be getting, no, c is not required for this case. Then I'll be getting 25 by, I'm sorry for that, printing error. Yeah. So 2a over 25 by 7 plus of 9 by 3 minus of 30 by 5, that is 6. So 3 minus minus of 3, right? So it's 21, that is 4 by 7, that is 8 by 7. Okay, so the 8 by 7 is the answer to this question. Next. Next question. Okay, next question is very much interesting, really. So this asks for the integral from 0 to 2 pi sine of x plus of cosine of x whole to the power 11 with respect to dx. Now, what makes this question special is that if you'll see, this is also periodic function. This is also kind of periodic function, right? We know that their periodicity are from 0 to 2 pi. And the thing is to be noticed is that this is also given in that factor only. In fact, this is total of 0 to 2 pi. What I'm trying to tell is that if you'll draw the graph of sine x, this is the interval, and for cosine x, this is the interval, right? So one thing could be observed here is that the degree is also E odd. It's odd. Okay. So from here, what I can do is that let us convert it into a single trigonometric term. So 2 pi, if I write here 1 by root 2 sine of x plus of 1 over of root 2 cosine of x with respect to dx, then taking root 2 whole to the power 11 outside, so that is 2 to the power 11 by 2, so it would be 0 to 2 pi sine of x plus of pi by 4, right, with respect to dx, and root 2 whole to the power 11. Now this is the thing to be observed. If you'll draw the graph of sine x, if you'll draw the graph of sine x, y is equivalent to sine x, then for sine of x plus of pi by 4, the function is getting shifted by left as we are shifting the functional input value towards right. Therefore, the function would be shifted like this. So yeah, here's the graph of sine, and as this is totally symmetric, this function is totally symmetric, and I can observe clearly that the area, look, this part is getting shifted. I mean, this part has got shifted there, and this has made it the recovery. So that means the net area is 1 combined plus 1, and the lower one is minus 1. So therefore the net area is 0. Or in simple terms, as we know that sine x dot dx from 0 to 2 pi is equivalent to 0 as usual. Okay, so the answer is coming to be 0. Yeah. Next. Okay, next question. Yeah, so the next question involves sine hyperbolic. So 0 to 2 pi sine hyperbolic x plus of cosine hyperbolic x whole to the power 11 with respect to dx. Alright, so we know that sine hyperbolic x, so sine hyperbolic x is equivalent to e to the power x minus e to the power minus x by 2, and cos to the power, cos hyperbolic x is equivalent to e to the power x plus of e to the power of minus x by 2, right? So this could be written as 0 to 2 pi, and if I'll add this, then I'll be getting ended up with e to the power of x whole to the power of 11 with respect to dx. So this could be written as 1 by 11 e to the power of 11x from limit 0 to 2 pi. So I'll be getting 1 by 11 e to the power 22 pi minus of 1. So yeah, here's the answer. This was a single liner question. Okay, next. Next is cosecant square x 10 to the power 2024 x with respect to dx. Okay, what does cosecant square need? What kind of I mean, what kind of substitution I should do there? It's simple. It needs cot. So let us convert this cot, this tan to cot. So I'll be getting cosecant square x over of cot whole to the power 2024 x with respect to dx. I'll take cot x as t. Okay, yeah, and as I'll take cot x as t, I'll be getting the integral of, I'm sorry, yeah, so integral of, uh, this will get cancelled up. So yeah, so cosecant square x, yeah, what, I don't think that there's need to any write it. It's directly getting into mind. So yeah, so minus of 1 over of t to the power 2024 with respect to dt. So it's getting to be 1 by 2023 t to the power 2023, that is 1 by 2023 cot to the power 2023, or more respectfully this could be written as 10 to the power 2023 x plus of c. Yeah, this was an indefinite integral, so it would be 10 to the power 2023 by 2023 plus c. Next question, question number 12. Yeah, so it was asking for cos to the power x cos x whole to the power of x, so that is log of cosine x minus of x tan of x with respect to dx. Alright, so as I can see there, one important thing that this cos x to the power x is of a form fx whole to the power gx, right? So for this case, what we generally do is that we take this as t. Okay, and one thing I can also see that this could be a derivative of this function. Yeah, this could be the f prime of x of this function. Okay, so it's very much important to substitute once, at least once, because it could work. So let us do it. Cos x whole to the power of x. Okay, not need to write like this. Let us directly substitute cos x as t. Yeah, so cos x to the power of x as t. So if I'll evaluate the integral, then this would be cos, okay, t directly, t log of cosine x minus of x tan of x minus of x tan of x with respect to dx over of cos to the power x x if I am now differentiating it. Okay, so dt by dx could be written as, okay, yeah, so dt, let me do dt by dx here. Yeah, so dt by dx could be written as cos to the power x over of d of, with respect to dx of x ln of cosine x. What I'm just doing is e to the power, I'm writing it as e to the power x ln of cosine x as t. Okay, I'm just doing this, and now I'm differentiating it using the chain rule. So I'm getting it as cosine x to the power of x ln of cosine x minus of x cot of x ln cos x minus of cos x. Yeah, so this is what I'm getting. Yeah, and it's exactly cutting it, minus of x cot of x. So yeah, it's cutting there. So t and t, this was t. Okay, so what we are left with is now just integral dx. So we are getting it as x plus c. Next question. Let me see the next question. Yeah, so it's integral minus infinity to infinity e to the power minus of x minus of 2024 whole to the power 2 by 4 with respect to dx. Okay, looks like there's a kind of feel. Yeah, I'm getting a kind of feel for Gaussian integral. So okay, we will see Gaussian integral later what will happen, but right now I'll be using the shifting property. Shifting property says nothing that, but if there's fx from a to b, then this could be written as f of integral of f of x plus of alpha dot dx. And if I am shifting this integral, okay, I am shifting the function by alpha, then the limits will be getting reduced by alpha, that is a minus of alpha b minus of alpha dot dx. This is known as the shifting property. So yeah, using shifting property of definite integral, we can write it down. So yeah, obviously negative infinity plus of if I'll do plus of 2024, then also it would be infinity only. So this would be minus of x by 2. Now I can write it down as x by 2 whole square, right? Now it's totally sure that this would be solved using Gaussian integral. So I'll be taking x by 2 as t, right? So negative infinity to infinity 2 e to the power minus of t square dt. Now this could be written as, yeah, so dx is equivalent to 2 dt for your convenience. Okay, yeah. So as we know that for Gaussian integral, okay, so for Gaussian integral it says that, okay, yeah, so for Gaussian integral, what does it says is simple, that from negative infinity to infinity e to the power minus of x square with respect to dx is regarded as root of pi. Okay, so it's regarded as root of pi. So this could be written as 2 multiplied by this thing is root of pi. So this would be 2 multiplied by root of pi. So our answer is 2 multiplied by root of pi. Next question. Next question. Yeah, question number 14. Question number 14 is 1 by e to e 1 minus of 1 over of x square e to the power of 1 plus of x plus of 1 plus x with respect to dx. Okay, all right. So as I can totally see that the derivative of this function is present there. If this is fx, then f prime of x is present there, right? So what I'll do is that I'll just substitute x plus of 1 over of x as equivalent to t. Okay, then I'll be getting e plus of 1 by e to e plus of 1 by e, and this will be getting cancelled. Okay, I'll show you. E to the power e to the power of e to the power of t dt by 1, the derivative of 1 x plus 1 plus x plus 1 by over x, that is x minus 1 over of x square. So 1 minus of 1 over of x square, so this is getting cancelled, so we are getting it from, oh, so the limits are same. And as we know that for any function, if the limits are same from a to a, then the integral is 0. The area under curve is 0, so the answer is 0. Next question. Question number 15. Question number 15 is, yeah, this is an clever one. E to the power x, e to the power of, uh, I just need to see the question because the question is not clear. Yeah, so where's that? Yeah, this one. Okay, all right. Yeah, okay. So for this question, one hope that I'm getting is that if I'll take e to the power x multiplied by x as t, then in that case I'll be getting 1 plus of x e to the power of x. But here we don't have anything, right? So what I can do right now is that let us write down it as, okay, so let us write it down as x plus of 1 minus of 1 over of e to the power of x, e to the power of x, e to the power of x with respect to dx. Okay, now just cross multiplying e to the power of x minus of x e to the power of x minus of 1, e to the power of x, e to the power of x minus of 1 with respect to dx. Okay, so yeah, this could be written as x e to the power of x plus of e to the power of x minus of 1. Okay, now I can clearly see that the derivative, if I'll substitute this whole part as t, okay, then t is equivalent to x e to the power of x minus of 1, right? So yeah, uh, dt over of dx is equivalent to 1 plus of e to the power of x plus of x e to the power of x minus, yeah, this one is x, right, minus of x minus of 1. Yeah, so this is exactly matching from here. So just I'll substitute it. So e to x e to the power of x plus of a, oh, I don't think that there's need to write it down. Okay, so there's no need to write it. So we are getting e to the power of t with respect to dt. So this is, yeah, so the answer is e to the power of t, where t, e to the power of t plus e, which is e to the power of x, e to the power of x minus of x plus of c. Yeah, and here's the answer to this question. Okay, next question. Next question. Uh, yeah, this is a good one. And it's asking to evaluate the integral of tan inverse of x over of 1 minus of x square plus of tan hyperbolic inverse of x over of 1 plus of x square with respect to dx. Hmm. For this question, I can see one thing, that these two terms, if I observe it very much carefully, then these two terms are related very closely, right? How they are related? If you'll observe, then the derivative of tan inverse of x is 1 over of 1 plus of x square, and the derivative of tan hyperbolic of x, tan inverse of hyperbolic of x, is 1 over of 1 minus of x square, right? So I can say that if I'll write it down as integral of tan inverse of x, then this is f, and plus of 1 plus of x square, then this is the f prime, right, multiplied by 1 over of, this is 1 over of x square, yeah, so multiplied by tan hyperbolic inverse of x, And if I'll assume this as g, then g prime would be 1 minus of x square here. Yeah, this would be g prime. So this is of the form f g prime plus of f prime g with respect to dx. So this could be written as tan inverse of x, tan hyperbolic inverse of x plus of c. And here's the answer. Next question. Next question. All right. So for question number 17, it's asking to evaluate the integral of summation k is equal to 0 to infinity sine of k pi by 2. All right. So sine of k pi by 2 x to the power k with respect to dx. All right. This whole summation. All right. So let us see that what we can do there. So for this question, okay, one thing is clear that if I'll observe the sine function, okay, if I'll observe the sine function, then I can see one thing that for different pi and pi intervals, I mean, for initially it would be 0 and then it would be producing 1, then it would be producing 0, then it would be producing minus 1, then it would be producing 0, then it would be producing 1, and so on. So one thing is clear that this will tend to cause a kind of alternating series, right? It will form a kind of alternating series with alternative terms. So this could be written as integral. Now I am opening the integral. So yeah, opening the summation, initially sine of 0 is 0, so 0 plus of sine of 1, that is 1, so x to the power of 1 plus of sine of 2, that is 0, plus of sine of 3 pi, that is minus of x to the power of 3. All right, and it would, and yeah, so and it would follow the similar pattern and or so on, yeah, with respect to dx. Now I'll integrate it, so I'll be getting x squared by 2 minus of x to the power 4 by 4 plus of x to the power 6 by 6 minus of x to the power of 8 by 8 plus of up till infinity. Okay, now the real thing arises that now how could I transform it, the Maclaurin series for ln of 1 plus of x. Why I'm taking ln of 1 plus of x? Because this is looking exactly for that. How? Just do one thing, take x square by 2 as common, 1 minus of x square by 2 plus of x square plus of x cube by 3, right? Yeah, plus of x to the power 4 by 3. Okay, yeah, x to the power 4 by 3, 4, yeah, okay, plus of x to the power 4 by 3 plus of x to the power 6 by 3, right? X to the power 6 by 6. If I'll be taking, yeah, it's correct. X to the power 3, 1 minus of x square. But yeah, exactly. So from here, I think that I should take x square as common from both the sides. So in that case, I'll be getting 1 minus of x square by 2 plus of x square by 3 plus of x to the power 4 by 3 minus of x to the power 6 by 4 plus of up till infinite, right? So this tells that this could be written as x square by 2 multiplied by ln of 1 plus of x plus of c, right? Next. Next question. All right. I think this is the best question. Sigma integral of x is equal to 0 sorry, n is equal to 0 till 2024, the year 2024, of x to the power 2 to the power of n minus of 2012 dot dx. Okay, first of all, after looking at this series, one thing that I should take as a first step, since it's given as in the nth term form, so I'll just integrate it directly. So it would become sigma integration of x to the power 2 to the power of n minus of 2012, right? No, it's 1012. I'm sorry for that. Yeah, 1012 with respect to dx. Yes, n is equal to 0 till 2024. So yeah, this is equivalent to I. So I could be written as from sigma n is equal to 0 to 2024. This question is totally of observation. So this could be written as x to the power of 2 n 1102 plus of 1 over of x to the power of 2 n, not x to the power but 2 to the power n. Yeah, so 2 to the power of n minus of 1012 plus of 1 with respect to, yeah, and the limits from 0 to, from where to where? Yeah, from 0 to 1. Exactly, from 0 to 1. So this could be written as sigma n is equal to 0 to 2024 1 over of 2 to the power of n minus of 1012 plus of 1. Right? Now, this is looking like a neither odd neither even function. Neither odd neither even function. And in general, these kinds of functions follow a separate kind of symmetricity, or you can say a second separate kind of behavior, which we can see right now. And if you will observe, if I'll take this as f of n as 2 to the power of n minus of 1012 plus of 1. Okay, if I'll take f of 1 whole to the power of minus 1. Okay, if I'll take this whole term as f of n, then for the highest degree for which we are going, if I'll take this as f of 2024 minus of n plus of f of n, then let us see that what we are getting. So this would be 2 to the power of 1 n minus of 1012 plus of 1 plus of 1 over of, now it's a time for 2024, so this would be 2 to the power of minus of n minus of 1012 plus of 1, right? So yeah, so we are getting 2 to the power of 1 n minus of 1012 plus of 1 divided by 2 to the power of n minus of 1012 plus of 1, and which is equivalent to 1, right? So from here, one thing that I can conclude through symmetricity is that f of 2024 minus of n is plus of fn is equivalent to 1, right? So this behavior which we are observing is the main game for this whole integral, or else this could be done using the convergence theorem, but okay, this is much better. So this symmetry is the main thing that we are observing here. Okay, so if I'll use the symmetry by putting one by one, so I'll be getting f of 0 plus of f of 2024 is equivalent to 1, f of 1, right, plus of f of 2023 is equivalent to 1, and f of 2 plus of f of 2022 is equivalent to 1. And as far as I'll go there, I'll be getting ended up at what's the middle number? 1012, right? So 1012 would be left by, because we are starting from 0, not from 1. Okay, so there will be a middle number left, so this would be 1011 plus of f of 1013, the middle number would be added separately, and if I'll observe, then there are 0, 1, 2, 3, 4, 5, 6, 7, 8, 0. So there are till 1012 plus of 0, that is 1012 term, right? So if in case, if I'll, not in case, but I'll add the summation, then in that case I'll be getting uh, it as uh, 1012, and the main thing is that we haven't add f of 1012. And how we can find out f of 1012? Just put it here. So after putting, you are getting f of 1012 as 1 by 2 to the power 0 plus of 1, that is half. So plus of half, plus of half. So this is equivalent to 2025 by 2. Yeah, this is equivalent to 2025 by 2. So here's our answer for this integral. Okay, next question. Okay, next question. Let me check up the next question because I don't have it there. Yeah, this one. All right. So yeah. Okay. So I'm seeing that. Look, what I'm seeing is that the highest degree is 4 and the highest degree is 4 on both the sides in numerator and denominator, right? So what I can do here is that, okay, I can, there's nothing like I will assume it as I, not an issue. So let us try to make um, what I can do. The first thing that strikes in the mind is to factorize it, but it's not even getting factorized. If I'll write this 4x cube as in the form of 3 and 2, no, not possible. 6 or 2, no, not possible. So let us try to create this exact term on the upper side. But note one thing, this is not always necessary that it would strike in the mind. This is the main thing. It may strike or it may not strike. And this is getting really very much weird sometimes. So let us try it. So integral half. Why I'm subtracting half? To make it the same on both the sides. So I'll write it down, 4x cubed plus of 6x squared minus of 6x plus of 3. Now I need to pay the debt that I have taken from here. So this would be minus of 4x cubed minus of yeah, so plus of 6x squared minus of 6x plus of 3 divided by 3 minus of 6x plus of 6x squared minus of 4x cubed plus of 2x to the power of 4 with respect to dx. Okay, so minus of 4x cubed plus of 2x to the power 4. Alright, so this and this term got cancelled. So we are left with half integral of dx minus of, okay, I'll remove this minus, half of 4x cubed minus of 6x squared plus of 6x minus of 3 over of 3 minus of 6x minus of 6x squared minus of 4x cubed plus of 2x to the power of 4 with respect to dx. Now, this degree, if I'll observe it very much carefully, then let me write it clearly. Yeah, 2x to the power 4. Okay. So if I'll observe it very much carefully, then I can see that the degree is 4 for this case. I mean for the lower one. And for the upper one, the degree is 3. So it can pose a condition where we can take this whole term as equivalent to t. Why? Because that only will reduce the degree till 3, right? So I can write it down as, okay, this would be x by 2 plus of half integral of half, let me take this as t, so this would be 4x cubed minus of 6x squared plus of 6x minus of 3 divided by t with respect to dt over of the derivative of t. What's the derivative of t? 8x cubed minus of 12x squared minus of 12x. Okay, yeah, so minus of 12x squared minus of 12x minus of 6 minus of 6, right? Yeah, minus of 6. Uh, wait, this should be plus, right? Yeah, plus. Okay, minus of 6. And if I'll take, uh, okay, yeah, this is getting cancelled out. So if I'll take 2 common, okay, then 2t, then this would be 4x cubed minus of 6x squared plus of 6x minus of 3. Cancelled, cancelled. X by 2 plus. So yeah, this is t. So this would be x by 2 plus of 1 by 4 integral of 1 over of t dt. So we are left with x by 2 plus of 1 by 4 ln mod of. Now what's t? That is, uh, that is, yeah, this one. That is 3 minus of 6x plus of 6x squared minus of 4x cubed plus of 2x to the power of 4 plus of c. And here's our answer. So thank you. So here are all the questions. So thank you. Hope you enjoy it. Hope you enjoyed it.